Welcome IGCSE students, we're looking at the sine rule today. So I think all of these questions in the exercise will be on the sine rule. I haven't done exercise 8.11 in this exercise because if you just follow the instructions carefully from the textbook, I think you'll be able to do that question without too much trouble. Okay, so I'm going to do a few examples for you here. You want to make sure as you work with the sine rule that your calculator has the right setting on it. So for our calculators, you want to make sure that up the top there's a little D. If you've got an R up the top, that means you're set to the wrong mode, and in that case you'll need to change things. So you would hit Shift, Set Up, and then I think number 3 is degrees, so you want to put it to that. Okay, let's get into this. When we're using the sine rule, as we've talked about in class, we need to pair angles and sides. So I'll look at this first one here. I'm pairing the x with the 42 degrees, and I'm pairing the 6.5 with the 54. Now, we put our unknown on top. So in this case, our unknown is a length, and then we put the sine of the paired angle with it, so sine 42. And we make that equal to, since we put x, the side, on the top, then we're going to put this side on the other side at the top, so 6.5, and then we're going to put that over the sine of 54. And we rearrange things to get x by itself, so x is going to equal 6.5 all over sine 54 multiplied by sine 42. Now when you put this into your calculator, make sure you put brackets around the angles, an ending bracket around the angle for the sines, otherwise you may end up in a few issues. So when I get through this, what am I getting? Sine 54 times sine 42. Okay, I'm getting 5.38. 5.38 to 3 significant figures. Okay. Now I'm going to move on to the next one. I'm pairing my angles and sides. So this side pairs with this angle, but this side, my unknown, actually pairs with an angle that I don't have. Not to worry, because I've got the other two angles, and so therefore I can figure out what it is. 60 and 50 is 110, so this angle must be 70 degrees. So there's a couple of those ones where you're not just a mindless fool carrying a calculator. You actually need to apply the rules. So you can use other rules like angles in a triangle add up to 180 to figure out an unknown angle. Okay, now, so we'll write x, our unknown, over the sine 70 is equal to our 6.3 over our sine 60. We rearrange that just like I did in the first one. So I'm going to have 6.3 over sine 60. I'm going to multiply that by sine 70, and I'm going to get x is equal to sine 60 times sine 70. Alright, okay, so I'm going to get 6.84 for this one. 6.84. And one of the ways you can check that you're on the right track is looking at the size of the angles. So this is a 70 degree angle, so we should expect x to be larger than the side that's opposite the smaller angle, and it is, so that's positive. Okay, let's move on to the next one. Well, this one we've got an unknown angle, and that pairs up with this, and we've got a known angle which pairs up with this. So since the unknown is an angle, we put the sine of that unknown angle on top. Sine x is over, and we put its paired side here, equals sine 75, and we pair that with the 8 there. Then we're going to rearrange the formula. So our next line would be sine x is equal to 6 sine 75 all over 8. And then to get x by itself, we go x equals the inverse sine of that whole thing. And again, make sure when you pop this into your calculator that you're using brackets around the angle and the sine. Now, when I do this on my calculator, hopefully don't make any errors here, 6 sine 75 all over 8. So I'm getting 46.4 degrees. x equals 46.4 degrees. Okay, now we'll move on to this next question here. This is one of the ones that you have to do in your work. So again, I've got to calculate the size of angle ACB. So we compare this with this, and we can this is opposite that angle up there. So angle ACB is our unknown. So we'll go sine ACB over its paired side, 2x equals, what have we got here? Sine 40 over its side, which is 3x. Now, I know some of you probably thought, oh, we can't do anything here, but just go ahead and try stuff. Always have a go, and sometimes the problems that you expect to have are going to iron themselves out, like they are right now. What do you notice? The x's cancel out at this point. So, now we can get ACB is equal to the inverse sine of 2 sine 40 all over 3, because of the x's being cancelled out. And so ACB equals, now let's do that, inverse sine of 2 times sine 40 over 3. I'm getting, it's 25.4 degrees to 1 dp. Okay, let's look at this next one, a little bit more complex. This also is one of the ones that you have to do. We've got these roads, these straight roads connecting points P, Q, and R, and we know the length of PR is 8. We know that the bearing of R from P is 55, R from P, so this is 55 here. Okay, so I'm just going to add that to my diagram, 55. And we know that the bearing of Q from P is 80 degrees, Q from P. Okay, now if that's 80, this whole thing is 80, then we know that this little bit here must be, was that 25 degrees, I think. 25, 30, yep, okay. Because altogether that has to add up to 80. Alright, and then the bearing of Q from R is 110, so we know that this is 110 here. And we also know that this angle here, because it's co-interior with the 55, we can go 180, take away 55, and so we know that this is 125. And therefore, since angles around a straight line add to 360, if we go 360 minus 125 minus 110, I think that gives us 125 also, 125. Okay, and let's see what we're actually trying to find out. We want to know the length of PQ. Okay, this is PQ here. This is our unknown. We compare it with this. And we know 8, and we can compare it with this angle here, which we can also find out. 125 plus 25 is 150, so this must be 30, because angles in a triangle add to 180. Excuse me. Okay, so let's do this. So unknown, x, over our sine 125 should be equal to our known 8 over its paired sine angle sine 30. And so therefore x is equal to 8 sine 125 divided by sine 30. And so x is equal to, now let's have a look what we get there. 8 sine 125, make sure you do your brackets properly. And then sine 30. Okay, I'm getting, it's 13 kilometers, 13.1 kilometers. 13.1 km. Well, guys, I hope that's a good little short intro that will help you go through this exercise. Good luck with that. Let me know if you have any questions.